Hello team, in this we're going to look at the common types of cloud business models. So one important question that cloud providers must ask is how to generate revenue. And this depends on how the company is structured and how it provides its services. For example, cloud providers need to decide whether they should handle physical facilities and computing facilities, or if they should maybe delegate some of these tasks to third parties. For example, air conditioning. So air conditioning is not exactly computing capacity, but it's required. So should the cloud provider handle the air conditioning itself, or should it hire another company to deal with the air conditioning? So this is an active decision that the company has to take. Same thing for power, physical security, and then for each of the main components of computing, for example, the network and the servers and the software that goes on the servers. So the cloud provider needs to decide how to handle these things, and we're going to look at 3 of the most common types. So these classes of cloud services we will look at are loose definitions, and there is overlap between them, but they help delineate what each company does and how they approach the cloud business. So the first business model we look at is called infrastructure as a service, where a cloud provider sells infrastructure. So infrastructure is made of physical resources. So the cloud provider will need a building, some power, air conditioning, and inside we'll have servers, network equipment, some data storage and load balancers for other appliances like firewalls. But the cloud provider doesn't sell the physical resources directly, otherwise we would lose all of the benefits from virtualization we saw previously. So what the cloud provider does is it sells virtualized resources that are equivalent or very similar to physical resources. So this is why it's called infrastructure as a service. It's like the cloud provider selling virtualized infrastructure. So cloud customers, when they're using infrastructure as a service, they rent virtual machines, they get virtual networking, they pay for block storage, they might use load balancers provided by the cloud. And when using infrastructure as a service, customers get a lot of control. Like we've seen before, they have full control of the operating systems running on the virtual machines, and of course, control of the applications that they run on the virtual machines. And the cloud provider can also sell complementary services to the infrastructure. For example, the cloud provider can have auto-scaling services to increase the number of virtual machines running an application when load increases. The cloud provider can sell automated backups or snapshots of the virtual machines to avoid data loss. So these complementary services are very common on infrastructure as a service providers. As examples of infrastructure as a service providers, we can cite all major providers like Amazon, Google, Microsoft. They all sell virtual machines and infrastructure as a service. Some of the smaller cloud providers like DigitalOcean and Linode also provide infrastructure as a service. So they sell virtual machines, but they might have less offerings around the virtual machines compared to Google and Microsoft, for example. But they still provide infrastructure as a service. Another common business model is called platform as a service, where a cloud provider provides a facility to allow a customer to build and deploy software. So like on the drawing on the right here, platform as a service is built on top of some physical infrastructure and virtualization. So it's very common for providers that sell platform as a service also sell infrastructure as a service because they probably have the infrastructure and the virtualization technologies in place to provide platform as a service. So platform as a service, as I said, is a facility that allows a customer to build and deploy software, and it eases this building and deployment of software. So the provider is going to manage the infrastructure for the customer. So the customer doesn't need to care about the infrastructure anymore. And it also doesn't need to care about part of the stack it will use to build its application. So the compilers, the libraries, the middleware, the automation tools, these might also all be provided by the platform. So the platform gives you this set of technologies that you can use to build an application. And then the customers, when they're using platform as a service, the main advantage is that they can focus entirely on their application and they offload all of these management tasks to the provider. A limitation of platform as a service is that the customer loses control of the lower layers. So the operating system is usually fixed by the platform, and the options at each layer might also be limited. So the user might not have all options available to it when it's building its application. So the choices, some of the choices might be made by the platform itself. As examples of platform as a service providers, we can cite Google App Engine, Windows Azure, AWS Elastic Beanstalk, and Heroku. So let's have a closer look at AWS Elastic Beanstalk to get a more concrete view of what platform as a service entails. So the Elastic Beanstalk introductory video does a very good job at selling why you would want to use Elastic Beanstalk to build your application. But looking at some key phrases in the video, we can exemplify what we were talking about in the previous slides. One of the phrases the video has is that it explains that Elastic Beanstalk makes it easy to deploy and scale web servers. So these makes reference to a specific type of applications. These are web applications or applications that rely on web services like REST APIs. And then it also says that you can build these applications using Java, .NET, Node.js, and Python. So there is a selection of languages and frameworks you can use, but if you want to do, say, Scala or Rust, something that's not supported by the platform, you will not be able to use it. It also mentions that these services, the web services, they're going to run on Nginx and IIS. So you don't have a lot of choices when choosing what web server you're going to use. So these are pre-selected by the platform. You have some options, but not a lot of options. And then by the end of the video, it says that you get all of these advantages, easier to deploy web servers without having to spend time managing and configuring infrastructure, which is the main point of platform as a service. So you have some limitations on what you can use, but you can focus entirely on building your application, and then the platform is going to take care of the infrastructure and automation and deploying upgraded versions, auto scaling, and so on. So like I said, one of the limitations of platform as a service is the lack of flexibility. If your application matches the functionalities that the platform provides, then it's great. You can build your application on that platform and it's going to work okay. However, if the application you want to build doesn't match the functionalities made available by the platform, then you might have some trouble, or it might even be impossible to use that platform to build your application. So this lack of flexibility might or might not be an issue depending on the application you want to build. Another possible problem is vendor lock-in. So each platform will have its own standard, its own limitations, and then if you build your application to match a given platform, it may be hard to move to a different platform because the capabilities and the functionalities might differ between platforms. A third business model is called service as a service, where you get a service and you usually pay with a monthly fee or yearly fee. So these services, they're built on top of infrastructures. So there's, service as a service usually employ infrastructure as a service to auto scale depending on how many customers they have. And these services, they are usually universally accessible because they run on the cloud. You can access them from desktops, laptops, tablets, phones, even servers. And it's very common for these services to have a web interface. So you can access them on your browser if you are on a computer. And if you are on a mobile device, you might have a platform specific client that you can install to access the service. One advantage of these services running on the cloud is that they guarantee synchronization. So you get the same data across all of your devices. So if you have a tablet, a laptop, and a phone, and you use a web service, you're gonna get the same data on all of your devices. So they're kept in sync. And this is good for depending on the application you're doing. Let's say if you use a note-taking application, it's great that your notes are the same across all of your devices. And because these services rely on cloud infrastructure, they are highly available. So it's very rare for these services to go offline because they run on the cloud. So the cloud usually takes care of masking failures when they happen. So if one virtual machine crashes, there are other virtual machines running, and the cloud can start more virtual machines to replace the one that failed and so on. So the users, they might, get one error message, but then they try again and then the service just, came back up because another virtual machine was created to keep the service running. So many subscription services could be classified as service as a service. For example, Office 365, Google Workspace are Office applications that run on the cloud. Evernote, for like note-taking applications like Microsoft OneNote, also classified as service as a service. TotalPlus could be classified as a web service, like service as a service because it runs on the cloud. Todoist, similar to Evernote, also running on the cloud. Dropbox, another example. So there are many services running on the cloud, and we usually pay them with a subscription. And like I said, these applications, they can run on multiple devices, and they usually have a web interface that we can access from our browsers. So these interfaces we use to access these services, they're called thin clients. So the code, the data, everything that's heavy remains on the cloud, and we just access that information on demand. So our phone, when we are using, say, Evernote, doesn't need to store a lot of data, and it doesn't do a lot of heavy computation. Everything happens on the cloud, and the phone just shows us the information we searched for example, or the note we're taking right now. Now, the service as a service model is great, but it also has limitations. So one is that the features available in the service are set by the provider. So the provider decides what new features to implement, and if that's not what you want, you might have to wait longer, or you might never get the feature that you want. For example, I would like Vim bindings on Google Docs, but it's never going to happen. So I'm just, going to have to use what they provide. There's also limited customization in most cases. So you might have some configuration you can do, but the customization is more or less limited because it's standardized across all of the users. And there's also lack of control. You can't change the service because it runs on the cloud and it's all proprietary. There's also limitations on interoperability. So some services might integrate with other services, but again, these integrations are defined by the provider, and the users don't have a lot of say into what integrations are available. So this is a possible limitation, and it might be hard or impossible to integrate web services with in-house applications. So if a company has a system that it uses on its network, for example, to manage some equipment, it might be very hard or impossible to integrate this system with a web service that it's using. And another problem is vendor lock-in. Say if you have a lot of notes in Evernote and you want to move to Microsoft OneNote, even if you can export your notes from Evernote, they might not be very easy to import inside OneNote. The set of features might be different, and then your notes might not look the same, or you might lose some information. So there's this vendor lock-in problem here as well. So here's a summary of what we manage and what the cloud provider manages on each of these business models. So if we're using a private cloud, then we manage everything, right? So we have control of the service, the network, the storage, the virtualization, the operating system, the middleware, the data, and the applications. So it's all ours. If we use the infrastructure as a service, we offload the infrastructure and the virtualization to the cloud provider. So the cloud provider is going to take care of the physical infrastructure and the virtualization, but we still maintain control of the operating system and what we're running on top of it. If we use platform as a service, the cloud provider will manage the infrastructure and the operating system as well as the middleware. So the middleware might take care of automating deployment, auto-scaling, building our applications, testing it, all of these things. So we only control the application and the data, so we can focus on building on our application, which is the basic premise of platform as a service. And if we use service as a service, then we don't control anything. It's everything run on the cloud. So the infrastructure, the operating system, and the application, and our data, so we push our data to the cloud, and it's all managed by the service.